Hi, this is Timothy Priscilla, and I'd like to work an example of a problem involving the future value of an annuity due for my Math 1324 class. Here's the problem. Find the future value of a 12-year annuity due with payments of $3,300 and an annual compound interest rate of 3.2%. Well, here they're specifically telling you that it's an annuity due. If they didn't use that phrase, if they said the payments were being made at the beginning of each period, then that should have keyed you in that you were looking at an annuity due. Annuity dues, payments are made at the beginning of the period. The future value of an annuity due formula is given by S equals R times 1 plus I to the n plus 1 minus 1, all divided by I. But then we have to subtract off that artificial payment. In my class, I go through using a timeline showing them how that formula is derived using an ordinary annuity, the future value of an ordinary annuity formula. But here you'll just have to take my word on it. And S, the future value, that's what we're looking for. R, the amount of the periodic payment. These people are depositing $3,300 at the beginning of each year into the account. We know that they're making an annual payment because the interest is compounded annually. For these annuity formulas to work, the compound period and the payment period have to be the same. If interest is compounded annually, the payment has to be made annually. And I, the rate per period, well, it'd be a 0.032 divided by, there's only one period a year, so it stays at 0.032. And N, the number of compound periods in a year, it's the same as the number of compound periods over the life of the annuity. It's the same as the number of payments into that annuity. They made 12 annual payments, so there are 12. N is equal to 12. Substituting into the formula, let me move this up a little bit, there. 1 plus I to the n plus 1, divided by I. But then we have to subtract off that 13th payment, that artificial payment that we didn't really make. We really only made 12 payments. Punching this into our calculator, with the glare, it's hard to see this display. I've already punched in part of it. Let's see. Can I get it to show? There. Ah, it went off. There. So I first of all punched in the 1.032 to the 13th minus 1. I simplified the numerator, hitting equals. Then I divided it by the denominator, hitting equals. I then multiplied it by the 3,300. That's where I have that 52,185 showing on the display. And then finally, I subtract off my artificial payment of $3,300. So minus 3,300. It looks like this 12-year annuity due will have grown to $48,885.22. They want it rounded to the nearest cent. Be sure to round the way accordingly, but don't round too early for my final answer. And once again, this is Timothy Priscilla signing off.